So I wanted to go back and talk about the precise definition of a limit with a very specific example in mind. So in this case, we're talking about the epsilon delta definition of a limit, and we're going to do a quick example where we find a delta. Remember that this symbol over here is delta. It's talking about an x value difference or distance. And we're looking for this x distance to show that the limit as x approaches 0 of f of x equals 2 when epsilon, which is a y value distance for f of x, is equal to negative x squared minus 3x plus 2. So again, we're looking to try to essentially make sure that I can find some x value, some x distance that I can be inside that would make it so that I'm this close, 0.25 close to 2. So let me go ahead and I'll show you what this graph looks like. So I'm going to switch over here. I went ahead and graphed the negative x squared minus 3x plus 2. Now, hopefully you guys pick up on the fact that, yes, the limit here as x approaches 0 is indeed 2. It's the y-intercept. Hopefully there's nobody questioning that fact. And so basically what I want to do right now is I want to talk about if my epsilon, my y distance, is 0.25, then that means I need to be within 0.25 of that value. So that would be between 2.25, and I'm going to make sure I write this as an equation so it actually graphs it, y equals. And the other one I need is 0.25 below it, so 1.75. So there we go. We've got that graphed. So essentially what I want to do is I want to try to find the x values that put my green graph right here between those two darker lines. So I want, again, this green graph to be somewhere in between those two lines. And so since I graphed it, it actually kind of makes my life pretty simple. So basically, it intersects here at negative 0.0857864376269. On the top and on the bottom, it passes through at 0.08. So if you notice, these are kind of giving me a hint as to what kind of numbers I need to pick so that I'm within this within this little area here. And so let me just take a guess. And so I'm looking at it and saying that says negative 0.08. That says positive 0.08. So if I pick pretty much any number that's below 0.08, it should work. So let's just, I don't know, try 0.07 and see if when I plug in those numbers, it gives me something in between here. And again, it's really nice to see this graph because if you notice in this graph, it shows me that it's continuing through this. It's staying all within this little bubble. There's no going outside this range. It's all just kind of continuing to decrease in here. So let's just plug in, like I said, 0.07 and see what happens, okay? So here I go. I'm going to plug in 0.07 in for x, and then I'm going to plug in the negative 0.07 in for x. I'm going to use it green, though. So if I do f of 0.07, I'm going to type in my calculator real quickly, negative 0.07 squared minus 3 times 0.07 plus 2. Let's see what happens. So if I get negative 0.07 squared minus 3 times 0.07 plus 2, I get 1.7851. Now, remember, I just want to be within 0.25 of 2. Well, that puts me at 1.75. So I'm within that the 0.25 of 2. So let me go ahead and plug in the negative 1 just to see what happens, negative 0.07. And so I'm going to plug in negative of negative 0.07 squared. That's still going to come out positive. Minus 3 times negative 0.07 plus 2. So let's see. Negative of negative 0.07 squared minus 3 times negative times 0.07. I've got 2.2051. Now, notice again, I just had to be within 2.25, I just had to be within 0.25 of 2. So that would put it at 2.25. And yeah, so I'm going to erase this really quickly and just kind of reiterate what I'm getting at. So, like I said, I wanted my x values to produce numbers between 1.75 and 2.25. Since I got, I'm going to do green again, 1.7851, and I got 2.2051, I'm happy. These are within this region, and again, going back to the graph, it's always just going to kind of stay in here. So a good solution here, a good example would be when delta is 0.07. That works in this case. But here's the other thing. Let me repeat. There's multiple correct answers. If you pick 0.05, it would still work. You would just be even closer than what I already am. They would be, these two y values would be even closer. You could pick even something smaller, 0.01. They would still work. I would even venture to guess that 0.08 would still work, because if I go back to my graph one more time, this value up here is negative 0.085, and this other one is positive 0.081. So, like I said, there's lots of answers that you can pick, but it always does help to graph it and kind of see what's happening, just so you can kind of get the intersections a little bit nicer. But so, like I said, again, we were just trying to find some x distance, which we chose 0.07, that made it so my y's were in this little interval that I wanted. Hopefully that helps. I'm going to do another example in just a hot second to kind of help clear up any other issues. So hopefully, if you're still stuck, this will help you.